The second section in Unit 2, modeling probability, is tree diagrams. Tree diagrams are good for modeling both theoretical and experimental probabilities. The probability of all options at a single level of the tree should add up to 100%. So if there's 4 options, then each of those 4 options should add up to 100%, 1 over 1, or a decimal value of 1.00. To find the probability of multiple events, you have to multiply going down the tree. Now I draw the tree going vertical, where each level of the tree represents a different event. And so I multiply going down and I actually add going across, and that's how I try to display it for the students. Here's a very simple example of a tree diagram. This is a theoretical tree with 2 possible events. The 2 possible events here, we're going to draw names, and there's only 3 names. And then after we draw a name, we're going to flip a coin. The options of flipping a coin is either heads or tails. A tree diagram is good for modeling both experimental and theoretical because it's pretty easy to label a tree diagram, and it's pretty easy to spread it out and use it however you need. A couple of things I've done here is I've done a couple different ways to draw the tree. Now, I don't always have to draw it triangular. I can draw it rectangular and put dashes to separate however many options there are. So I demonstrated that here in the first level, the first option with 3 names. Now I can put the names of each thing right here. Going back to that Simpsons paradox video, we have Joe, Bo, and Mo. And so notice it's pretty simple to label that there. Also, to put the percentages or the fractions, you can space it out however you need to. And then the second level, if Joe's name is drawn, then the coin can be flipped to be either heads or tails. And so then we put heads or tails on each branch of this second level of the tree. And notice all options of this level right here, so the only options are heads and tails, that adds up to 1 over 1. Here this adds up to 100%, and this adds up to 1.00. Also, this adds up to 3 over 3, reduces to 1 over 1. This is a quick look at a pretty simple experimental tree diagram. This is a pretty quick look at a very simple experimental probability tree diagram. Suppose you go and survey people at a Denny's and ask them the type of meat they got on their breakfast and the type of bread they got on their breakfast. 5 out of every 11 ordered bacon, 6 out of 11 ordered sausage, and you notice 5 plus 6 makes 11 out of 11. So this level here adds up to 100%. Also, I made sure to show the different probabilities that add up to 1 in various ways. 37% plus 0.25 is 25%, plus 19 over 50 is 38%. All those add up to 100%. And then also different ways that you can label it. You can write the words, of course, or you could just abbreviate if you need the space. And then to demonstrate the operations throughout this tree diagram, we have a couple very simple probability questions. What's the probability someone got bacon and pancakes? Well, that spans 2 levels. This is multiple events. So we have to take bacon, which is 5 over 11, and then we have to multiply it by pancakes. And then 0.25 is the same thing as 1 over 4. So this is 5 over 44, which would give you the probability of these multiple events here. The probability of not bacon and not biscuits, well, you have to take everything that's not those 2 things. So sausage is 6 over 11, that's not bacon, times the probability of the toast and the pancakes. The toast and the pancakes adds up to 62%. So 62 over 100. If you want to keep it in fraction form, then you can multiply it there. Now, in doing the operations here, I know that I made the mathematics a little more difficult because you had to convert between different styles of a number. But in reality, when you teach this or when the students do this, they're going to make everything the same form. So they're going to make 37%, 25%, 38%. Or they're going to make this a fraction, and this a fraction. They're going to keep them all in the same form because that's going to make the mathematics easier. I, however, just wanted to demonstrate the different formats that you could see the probabilities shown. And that's tree diagrams.